I won the Patents for Humanity Award for this invention some time ago, but the way I got the idea that led to the invention is fairly interesting. I woke up one morning. I'd been, just retired or almost retired for some period of time, and I woke up one morning, sat up in the bed, and one of the thoughts that had always been in the back of my mind was that there are millions and millions of people that don't have access to water. And so when I woke up, just a revelation seemed to occur, and I had the idea of how to build a drill that would drill through gravel and sand and clay and rock, and would remove all of that material to the top of the ground so that you could set a screen in and get a well. It was a real, what many people would call a calling to service. And so I moved forward with that. And after a period of time, I built a drill and tested it. Ended up testing it in the United States. I think I drilled about 38 wells, 28 to 38 wells in the United States. A few years later, I had, maybe 100 wells, and now we're over 710 wells in India and Africa, and Central America and South America. The most important thing about our method of drilling is that it'll drill through gravel, which no other manual system is able to do. It cleans the well. In a well, there's often clay mixed with the water, and when you're drilling, and that clay goes into the formation, the aquifer at the bottom, and there's a phenomenon called thixotropy. And what that thixotropy does is it allows a mud to become a liquid while it's being moved, and once it stops moving, it becomes a solid. So millions and millions of wells have failed. In fact, as many as 60% of the wells in some areas in the world have failed, and people are without water, even though they have a well. So what my invention does is it does not put high pressure water jets at the bottom of the drill stem. In fact, it works in exactly the opposite way. It takes the drilling mud that you're using and brings it up from the bottom of the well to the top. So our method has what's called a low downhole pressure, and we're able to put in cleaner wells than other methods of drilling. And Mary, it looks like you've got the video up. I'm sorry about that. I don't know what's wrong with my computer, why it won't open. But
hey, that's okay. We have a beautiful presentation here. So just tell me when you'd like me to advance the slides, Russell.
Okay, if you hit it one time, it'll start the video part. What this is one of our wells in India. We've done over 400, I think 425, something like that right now in India. This is in the near Bhubaneswar and Puri. It's halfway between. And the well is pumping about 300 liters a minute. That's a 20-liter bucket. That's pretty much an average amount of water for our drilling system in an alluvial plain with a 8-inch borehole and a 4-inch casing. What we're doing in India is we have a number of people that we've trained. We've trained several hundred people in India. What we need is we need to be able to get those people drilling equipment. I think a drilling rig and complete setup is around $1,200. So we've got hundreds of drillers trained. We need to get equipment in their hands. And each one of those people that gets a drill rig can drill between 100 and 150 wells a year. So it's a fairly quick process. if my computer were working, I could bring up a screen and show you where the efficiency of our drill. We can get enough water for the entire world before 2030. Now if you'll click it again, this will open up I think it's the Water Texas Film Festival. We won that festival in 2020, I think. So go ahead and click on that. And yeah, there ought to be a spot you can click and it'll run a video there. Well, this is just, there we go. Well, go ahead to the next one if you want to. Okay. It's a real good video. I hate for you to miss it.
I think it's in the chat. Yeah, we'll add it to the chat. Okay.
Okay. If you could see the video, you could see the volume of water coming out of that's the drill stem. That is the first method that we use to, under my patent. There's a mathematical formula that determines the velocity of the fluid within the pipe. And that formula makes it possible for a person to drill with a reverse flow drill by hand. And that's the whole basis of the invention, is to get it where you can drill reverse flow. The reason why is because reverse flow, of course, gets large diameter particles and drill through clay and just about anything you want to do with it.